Hello, we will discuss today a very important law called the Weiss Zone law. It is a very simple law and gives you the condition. So, the Weiss Zone law is condition for a direction UVW for a direction UVW to lie in, or which is the same thing in crystallography at least, is parallel to condition for the direction UVW to lie in or is parallel to a plane HKL. Notice the direction indices UVW is put in the square bracket and the plane indices HKL is put in round bracket. You will recall this convention from our previous discussion on Miller indices. Now, Weiss Zone law is simply stating what is the condition that these two Miller indices satisfy if the direction is lying in the plane or is parallel to the plane. And the condition itself is quite simple. All you have to do is to multiply the corresponding indices, the first one with first one, HU, then KV, and then LW, and add them. And this sum of the products HU plus KV plus LW should be 0. So, the law itself is quite simple, but it is very useful and powerful law, as we will see as we go along in our crystallographic discussions. And one important thing to keep in mind is that this law is true for all crystal systems. We will see some of the applications of Weiss Zone law. So, just recall Weiss Zone law. It states the condition that if a plane HKL contains a direction UVW. I will again remind you, round brackets for the plane, square brackets for direction. So, if a plane HKL contains a direction UVW, then the Weiss Zone law, then by Weiss Zone law, I am writing it in acronym, we have HU plus KV plus LW is equal to 0. This law is very useful in solving certain crystallographic problems, and we will try to do that now. We will take as an example. So, let us take as an example problem of trying to find a common direction. So, direction common to 111 plane. So, let me 111 and 11 par 1 plane. So, I have been given two planes and I want to find a common direction. So, let me, I will do it two ways. The first will be the geometric method, that is by actual drawing. and the second will be the algebraic method by use of Weiss Zone law. So, let me draw a unit cell. So, this is my unit cell. Let us choose our axis convention. So, I am calling this x, this y and this z. With this, I am now ready to draw my first plane, the 1 1 1 plane. Recall that the 1 1 1 plane, the Miller indices of any given plane is reciprocal of the intercepts. In case of 1 1 1, that is not a problem, the reciprocal is also 1 1 1. So, this plane intersects the x axis at 1, and 1 means equal to the unit cell edge length. So, at x axis it intersects here, at y axis it intersects there, and at the z axis it intersects there. So, we get these 3 points 1 1 1, and if I join these 3 points I get my plane. So, if I call this A, call this B and call this point C, then I can write that ABC is 1 1 1 with, let me take that origin O, with O as origin. Now, I want to draw the second plane 1 1 bar 1 with the same axis and same origin. If I want to draw it with the same origin, I see that now the intercepts are 1 along x. So, I will get the same point, 1 along y, I get the same point, but 1 along minus 1 along the z axis. So, I really have to go in the negative direction of the z axis to find the intercept of this new plane on the z axis. So, the third point is here. So, let me for reference, let me draw a unit cell which is a unit cell lying below this unit cell. Let me draw it in blue only. So, I have a unit cell now. And I put my plane, let me call this point D. So, ABD becomes 1 1 bar 1 again with O as origin. I have not changed the origin, and since I did not change the origin, I have to take another unit cell and I have to go in the lower unit cell to draw the second plane. Now, what is the common direction? Just by inspection, I am seeing that AB direction, AB is common to both the planes. So, the AB becomes my common direction. So, by observation I find that AB is the common direction. And how do I find its Miller indices? Well, I can now choose A as my origin and try to move in the direction A B. To do this, I take a negative 1 step along x and a positive 1 step along y, and I do not have to go along z. So, positive negative step along the x axis, a positive step along y and not moving along the z. So, just by observation and drawing, I can find the common direction as bar 1 1 0. So, I have solved the problem of finding the common direction to these two planes by actually drawing. Let me try to draw the same thing in a different way. Suppose I am fond of my unit cell and I do not want to change. In the first case, I was fond of my origin and I did not want to change the origin. Now, I like my unit cell and I do not want to go outside this unit cell. If I insist that, then also it is possible to draw these two planes in the same unit cell. So, let me try to draw these two planes in the same unit cell. So, the first plane is as usual as in the previous drawing, it will intersect the unit cell axes at A, B and C, and I draw these lines. And I get again A, B, C as 1 1 1 with O as origin. But now, if I want to draw 1 1 bar 1 in the same unit cell, I will have to shift my origin. This was the O origin, because if I keep the origin fixed, then the bar 1 will take me outside the unit cell. So, if I want to keep myself within this unit cell and still be able to draw 1 1 bar 1, what shall I do? So, since I have to take a negative step, I have to shift the origin to the top face of the cube, so that I can go in the negative direction and still remain within the unit cell. And I still have to take positive steps along x and y. So, if you think about it, you can convince yourself that C now is the correct choice of origin. So, I shift the origin at C, my new x and y axis are now passing through the new origin, and from here I take one step along the x, that brings me here, one step along y, that brings me there, and one step along negative z, that will take me there. So, now the new representation of the same 1 1 bar 1 plane in my drawing will be like this. So, let me call this now D and E. So, ODE I have drawn as bar 1 1 1. Now, the origin is shifted with C as origin. But what about the line of intersection? Well, this requires a little bit of seeing. Observe that I have drawn one of the plane in black, the other in green, and on the left face of the cube, one of the black line is intersecting with the green line. So, one of the intersection point of these two planes is lying on the left face, and I call that P. another intersection point is on the back face of the cube. Again OE is lying on the green plane, BC is lying on the black plane. So, the common point to the two planes are this point Q. So, center of the left face and center of the back face now are common to both the planes. So, obviously, this entire line, if I have found two common points, the entire line will be the common direction. So, now PQ becomes common direction. But how do I find the indices of PQ? Note that in the triangle CAB, in triangle CAB, PQ, P is midpoint, midpoint of AC, and Q is midpoint of BC. And in any triangle, if you join the midpoints of two sides, it is parallel to the third side. So, PQ is parallel to AB, and we know that parallel directions all have the same Miller indices. So, PQ will have the same Miller indices as AB. So, we can now index AB by taking origin A, and exactly like we had done for the AB in this figure, on the left figure, we go one step minus one step along x, one step along y to come to B. So, the Miller indices of the common direction turns out again to be minus 1, 1, 0, as it should be. So, there are two different ways of drawing. In the first case, in the left case, I have drawn the two planes in different unit cells with a common direction. Now, I have drawn both the planes in the same unit cell, and I have drawn the common direction. The Miller indices come out to be the same. Now, to demonstrate the application of Weiss Zone law, we will do the same problem by Weiss Zone law. So, direction common to 1 1 1 and 1 1 bar 1. So, now the second method, algebraic method, I will call that, by the use of Weiss Zone law. In this, I do not have to make any drawing. So, if you want to avoid drawing, this is a good method. So, you can do algebraically, or you can write a computer program to do this in a much more easy way. So, here we will assume, let us assume, let the common direction, this is what we want to find out. So, let the common direction be UVW. Now, since UVW, since it is a common direction, it lies in both the plane. So, it lies in the first plane. So, since UVW lies in 111, we have, by the application of Weiss Zone law, U into 1 plus V into 1 W into 1 is equal to 0. Or U plus V plus W is equal to 0. Let this be the first equation. Again, since UVW also lies in the second plane, we get another relation. One bar 1, we have, again applying Weiss Zone law, we have 1 times U plus 1 times V minus 1 times W is equal to 0, which means U plus V minus W is equal to 0. This is our second relation. Now, just by taking these two relations together and manipulating them, we can find the direction UVW. Of course, we have only 2 equations and 3 unknowns, but really there are not 3 unknowns, but 2 unknowns, because remember that we only need to find the ratios of UVW and not UVW independently. So, these 2 equations are sufficient to solve our problem. So, we do that now algebraically. We can see that if I add 1 and 2, then we can get rid of W. So, I do that. So, 1 plus 2 gives me 2U plus 2V is equal to 0, which in the end gives me U is equal to minus V. So, I have established a relation between U and V. Let me call this relation 3, and if I subtract 2 from 1, so 1 minus 2 gives me 2W is equal to 0, which means W is equal to 0. And if I take the relationship 3 and 4 together, so this will tell me that UVW, the Miller indices UVW, can be written as minus V 0. So, instead of U, I have written minus V by 3, and I have left V, and instead of W, I have written 0 by 4. So, this is by 3 by 4. So, 3 and 4 gives me this, but now I know that I can divide by a common factor in case of Miller indices. So, by dividing by V, I get bar 1 1 0. Dividing by V. So, you can see that you have got now the same Miller indices bar 1 1 0 as you had got in the method by the method of drawing, by the geometrical method. But here you did not have to draw, just use algebra and the Weiss Zone law, and you will be able to find the answer. And of course, the two answers should match. If you have done both the methods correctly, if you have applied the methods correctly, you will get the same answer. So, beginning students should actually use both methods, both the Weiss Zone law and the drawing, to become familiar with both the methods, because drawing is also important. It gives you the perspective view and it helps you in imagination, whereas in the Weiss Zone law you only do an algebra and get the answer. But you should be familiar with both the methods, and that is why I have solved one problem by both these methods. So, we will take up some more example and other problems in future videos.